Welcome to Physics Review. In this lesson we're going to be going over simple harmonic motion. The problem states an object is attached to a spring and set into oscillatory motion. The period of oscillation is 1 second. The spring constant is 3 meters per second. Find part A is find the frequency of the oscillation, and B, find the mass of the object. One thing to note on this problem is part A and part B are not related to each other, so it doesn't matter what order you work them in. However, for the sake of going through it, we're going to do part A first. So in order to find the frequency, we're going to use this equation that I've already put down here. We're going to use F, the frequency, is equal to 1 divided by the period. Okay, and so in the problem it states that the period, which is denoted by T, is this right here, 1 second. So it just so happens in this case that the frequency is equal to 1 divided by the period T. And since the period is 1, it's 1 divided by 1, which is just 1. So the frequency is 1 oscillation per second. So it's actually like oscillation per second, or that's also known as 1 hertz. Okay, so this is that's actually the final answer for part A, right there. Now on to part B. The equation to use for part B, it's wanting to know the mass of the object, and the formula that relates the mass of an object to the period of oscillation is the period T is equal to 2 times pi times the square root of the mass divided by the spring constant. One thing I've noted both in class and I'll note here is on your calculator, whenever you're doing these problems, make sure to put pi as the actual pi key on your calculator. For physics 3.14, it just doesn't cut it. It's not precise enough. It actually needs to be more like 3.141592, etc. So do not use 3.14. Pi is not equal to that, okay? So make sure not to use 3.14. Make sure to actually type in pi on your calculators, okay? And that'll help you get a more accurate answer. So let's go ahead and start doing this. Again, the period is given by this time here. The spring constant is given over here, and it's noted by this 3 Newton per meters. So that'll be our spring constant. And the thing that we're actually looking for is this mass right here. So this right here will be the variable. Now, to solve for that, let's go ahead and begin inputting variables. The period, which is, I'll go ahead and write it down here. So the period is equal to 2 pi times the square root of the mass divided by the spring constant, which is 3. Okay, in order to solve for this, the first thing we need to do is we need to get rid of this 2 pi. So let's divide both sides by 2 pi. And we're left with 1 over 2 pi is equal to the square root of the mass divided by 3. Okay, and for those of you who are having trouble paying attention, right here is a squirrel playing a banjo. So for those of you who struggle with ADD, oh look, there's a squirrel. Now back to our problem. So we have 1 divided by 2 pi. I messed up our line there. Okay, so 1 over 2 pi is equal to the square root of the mass divided by 3. So, to finish solving for this, essentially what we need to do is we need to square both sides. Square. And we're left with 1 over 2 pi squared is equal to the mass divided by 3. And now if we multiply both sides by 3, we're very close to our final answer. And our final answer will be 3/4 times, I'm sorry, let's go ahead and erase that. The mass will be 3/4 pi squared. Okay, and if you want to do that on your calculator, I'll type it in here real quick on mine so I can give you the answer. 3 divided by 4, and make sure on your calculator, whenever you're typing this out, make sure to put 3 divided by 4 divided by pi squared. And our answer comes out to the mass of this object was actually fairly small. It came out to be 0.76. It's approximately. I'm sorry, I messed up again. Hang on. I just wrote down wrong on my calculator. The mass came out to be 0.076, approximately 0.076 kilograms. Okay, and that can. Okay, so let me recap this real quick. The answer for our second part was 0.076 kilograms. That would solve for the mass in part B. And the first part asked for the frequency, and it was 1 hertz. So that concludes this problem. And make sure to come back for more review later on.